Okay, guys, the last chapter of last section of chapter 5, the derivative of y equals tan x. There's the function tan x to the left in green. That's just an image capture from the internet. We've graphed in Desmos before. We know how to change those settings, so I'll leave that for you guys to play around with and decide. Just a quick review of tan function. So the period is a repeated cycle, pi, and the asymptotes, the vertical asymptotes, are every pi over 2, and then 3 pi over 2. So the first one starting at pi over 2, and then they go up in increments of pi in repeated vertical asymptotes. So the focus of this chapter is what's the derivative of tan x? The derivative of tan x. Well, one real neat, simple little way to find the derivative of tan x, right, is to use the identity tan x is equal to sine x over cos x. Okay? And you can then develop the derivative of tan x using the quotient rule, okay? Or the product rule if you like. Okay, here's a proof right here, pretty straightforward. I write it as a sine over cos, and then write tan x as a product, sine x multiplied by cos x to the negative 1, and then I do a product rule. You could also do a quotient rule with this function right here in order to get tan x. Either way you do it, we realize and get basically a real quick, it's not necessarily a proof, it's more of an identity, but we do get the result that y prime is equal to secant squared x. Okay, this particular chapter is really short. Okay, so we are going to do just a couple of examples that focus on this. Okay, and this row basically, both of them are the same. Tan x prime is equal to sine squared x, or if y equals tan x dy dx. Okay, so Leibniz notation is secant squared x. All right, composite rule for tan functions. Okay, so if I have the tan of a function and I want to find the derivative of it, I take the secant squared of the function and then multiply that by the derivative of the function itself, and that's just the rule for tans of composite functions. So here's the first one. Okay, so I take the derivative of tan, that's secant squared of my composite function, then I make sure I multiply it by the derivative of that function. Okay, now normally I write the constant out in front. Okay, in this case the constant is actually just a polynomial. Okay, that's the proper way to do it. So it's the secant squared of this piece, then multiplied by 2x plus 3. Okay, this next one is a product rule. Okay, so I've got x and then tan of 2x minus 1. And the derivative of x is 1, and the derivative of tan 2x is 2 secant squared 2x minus 1. Okay, so my derivative function using the quotient rule is 1 times tan 2x minus 1 plus x times 2 times secant squared 2x minus 1. Okay, I'm going to write that, take a minute and write that out here in its full entirety. I should have anticipated that earlier. Okay, but I'll write 2x and then secant 2x minus 1. Okay, I can clear the 1, and I have a function, and quite a complicated long function. But again, our original function was a product, and we had a trig function in here. That's what we've got here for this type of situation. Okay. Let's do a couple more here. Okay, it's the rule that you just need to know here. That's it. All right. A power rule. Okay, so y would be 4 times sine x plus tan x. That's going to be my composite function. to the power of 3, and then multiply by the derivative of this inside function. Now the derivative of sine x is cos x, and the derivative of tan x is secant squared x. I just close my bracket here. This next one's another product rule. Okay, so my product's going to be x squared and tan x. X squared is 2x, tan x is secant squared x. So the application of my product rule is going to be 2x tan x. Okay, those are the ups, plus x squared secant squared x. Oh, the derivative of cotan. Well, the derivative of cotan is not one we have learned about. We know y equals sine x, the derivative of sine x, cos x, tan x. Cotan, though, is just 1 over tan. And we don't really necessarily need to know all 6 trig functions and their derivatives. Okay, if we learn some and use some basic properties of trig, like in this example, cotan is equal to 1 over tan, now I can develop the derivative just using the quotient rule. Okay, this quotient rule, I'd use 1 and tan x. Derivative of 1 is 0. Derivative of tan x is secant squared x. So now I just use the quotient rule. 0 times the tan of x. Take away 1 times secant squared x all over tan x. Simplify the 0, okay, I have secant squared x over tan x, and secant squared x over tan x squared, okay, is equal to secant squared x minus secant squared x over tan squared x is equal to, it's a little different, okay, negative 1 over cos squared x divided by, okay, sine squared x over cos squared x. Okay, if I flip and multiply, my coses will cancel out. So I have negative 1 over sine squared x, and negative 1 over sine squared x is negative cosecant squared x. Okay, so what was the original question there? Cotan x has a derivative of negative cosecant squared x. The next one and final one here is, okay, this one here, tan, okay, of the square root of x squared plus 1. This might be a little bit more challenging here. Let's see if we can get that one. Okay, it looks like there's 3, okay, composite, 3 functions, right? So 2 chain rules. Okay, so the derivative of tan. Okay, I'm going to take the derivative of tan. The derivative of tan is secant of my function. Okay, then multiplied by the derivative of the square root function. The derivative of the square root function is 1/2, and then whatever the function is, okay, whatever the function is, to the negative 1/2, and then I have to multiply that by the derivative of the inside function, and that's 2x. Okay, so did we see that? Lots of stuff here going on. This is the derivative of the tan function. This is the derivative of the square root function, and this is the derivative of the polynomial, the quadratic function in here. All right, some challenging ones here. I think we've done these already. For some reason, they were just the last 2, or sort of the last 3 that was on the previous slide. Yes, so there's the x squared tan, the cotan, and the other one. Okay, that's it. That's it for this particular section. Okay, hope you enjoy, and good luck with the homework questions.